Today, I will be presenting my course project in Physics 102, which is magnetic field around a straight wire. So the aim of the experiment was to show the relationship between the magnetic strength around the wire at different currents. So the distance will be kept constant, while the current will be changed throughout the experiment. And the materials that I am using are a DC power supply, a straight copper wire, an ammeter to measure currents, and this will be connected in series, a magnetic field sensor, for which I will be using a magnetometer app on my phone, and a ruler for distance measurement. So here is my experimental setup. First of all, I have a 10 ohm resistor. After that, I have my magnetometer app. Then I have an ammeter connected in series, and finally I have a DC voltage supply. You can also see the very long copper wire as well. Here I am doing my experiment. So what I was doing throughout the experiment was basically increasing the current passing through the circuit by 0.25 increments, and I recorded the values that I had seen on the magnetometer, and I did this several times from 0.5 to 2 amperes, and as you can see here in the ammeter as well, the current fluctuated, and I think this is largely due to the change in the resistance of the resistor due to the heat buildup, since the current passing through the circuit was sometimes a bit too much, so I had to stop and restart the DC supply over and over again. So the results of my project are as follows. Normally, I had only the current and the magnetic field values in the table for my proposal, but I decided to include the voltage values as well, because when you divide the voltage by the current, you can see that the resistance fluctuates due to heat buildup as the current passes through the wire. So I plotted the magnetic field data points for each current value, and then I drew a regression line. And the slope of this regression line will give us B over I. So we had calculated the slope of the regression line as 1.45. We will calculate the error rate by comparing this with the theoretical slope. So we will calculate the error rate by comparing the experimental slope with the theoretical slope. And I calculated the theoretical slope by B over I enclosed. The calculation is shown here as such. And as you can see, the theoretical value of the slope will be 2 microteslas per ampere. And when we compare this to the experimental slope, we find that the error rate is 27.5.